Alright, so today, gosh, I thought I was all set up. Where's my pen? I am not ready. Alright, so, today's date, 11/29. Okay, topic is arithmetic sequences, but we're going to use the explicit formula today, okay? So arithmetic, and this is what Zoe said. Zoe said it's linear. Arithmetic means to add the same thing each time, right? And it does make a straight line because you add the same amount each time, which makes sense, okay? The explicit formula, though, is the better formula. Remember now, n is always going to be these numbers, 1, 2, 3, 4, ... because it represents the first term, the second term, the third term, the fourth term, so forth and so on. We did the recursive formula the last couple of days, and the problem with the recursive formula is it doesn't help us get far ahead. Like, for instance, if I need to know the 100th term, with recursive, you'd have to just keep adding and adding until we'd made a whole column like Julia did, and I really appreciate you did, Julia. But you'd have to make the whole big long list to find out what like the 30th term was. So obviously there's a formula, and the trick to the formula is it helps you go straight to that 30th term, okay? So the explicit formula is this. It is your a of n equals a1 plus n minus 1 times d. So a of n represents the term you want to make. A of n represents, so if it's a of 10, it'd be the 10th term. If it's a of 5, it's the 5th term. If it's a of 100, it'd be the 100th term. So if n is 100, then that's your n number. D is the difference, right? Whether you're adding 5, subtracting 2, that's the difference. And so it makes it a lot easier to find, say, the 50th term. So let's look at example 1. Example 1, find the 50th term of 8, 14, 20, 26. Okay, now, again, we could just keep making it until we get 50 terms. What a drag and what a waste of time, right? So if we use our formula, in this case, n would be 50, because we want our 50th term, all right? So we're going to set up our formula. We're going to go a of 50, because we're looking for the 50th term, is equal to a1. Well, the first term is 8 plus n, in this case, n is 50, right? So we'll go 50 minus 1 times d, and d is the difference. In this case, d is up 6. So we write up 6, so it's times 6. Okay, so then, just to make it easy, I'm just going to use a calculator. I'm just going to let the calculator do the work. So I'm just going to go straight to 8 plus 50, subtract 1, times 6, and it goes straight to it. So the 50th term really is 302. Bam, right to it, right? A lot better than just making it all the way to the 50th term. We know that A50 is going to be 302. Okay, pretty easy. So again, just to recap, if I needed the 50th term, n is 50, I want to use my explicit formula. So a of 50 is equal to my first term, which is 8, plus n, and since n is the 50th term, I use 50 minus 1 times d, and d is the 6 because it's the difference between each term. Put in the calculator, boom, 302. So if we just keep adding, we'd go all the way to the 50th term, would have been 302. Yeah, Cole?
This is a stupid question, but what does the A mean?
The A or T is just a symbol for the term, okay? The book likes T. This particular stuff we do, sometimes they use K, right? I like A. Most of the books I've ever seen use A. Some books like T for term, but a lot of books don't like T because T means time. Does that make sense? So it just represents the first term. So it wasn't a bad question at all. It was a good question. Okay, so let's take a look at, so the band now, we got back to our band, the Stellar Band. This recording company tracks the number of compact discs that Stellar Attractions sells each week. During the week of June 10th through 16th, the band sold 9,050, okay? Sales projection indicates the band expects weekly sales to increase by an average of 2,353 copies each week. So every week we're going to add that to our thing, okay? These projections are shown in table 3. So we got week 1, week 2. Week 2 is made by, they just added, right? They just added 2,353, added 2,353, you can add 2,353, Saul, this is for you, okay? Office now. So anyway, what we could do, and I'm not going to, what we could do is just keep adding to get all the way to December, right? To get the 29th. But that's a waste of time because we have a formula. So the explicit formula allows you to go straight to it. So the explicit formula, let's use it. A of n equals a1 plus n minus 1 times d, right? So let's just use our explicit formula. We need, let's see, the 29th week. So we're going to let n equal 29, right? We need the 29th week. So we're going to go a of 29 equals our first term, and our first term is our 9,050 plus n, which is our 29th week. So we're going to go 29 minus 1 times d, and d is the difference what we add each time. So we're just going to multiply that by a 2,353. And again, nice job, Ben. I'm going to show up, but yeah, I'm sure you're right. So we're just going to use the calculator. Ben already has the answer. Let's do it real quickly on the calculator. So I'm just going to go 9,050 plus parentheses 29, subtract 1 times my 2,353. Boom, there's my answer, right? So it's a lot faster. It gets you to that answer quickly without having to make. So it's a good formula, isn't it? Owen, question.
So I'm not sure if this is skipping a step, but instead of the 29 minus 1,
right,
could I just do 28?
That's exactly what we did last night. When I was helping Lan with the homework, we didn't even subtract 1. Totally right, yes. Yeah, absolutely, thank you. I just know, being the teacher, I just show every step, right? So, you know, my guess, if I put 28, somebody'd say, Mr. Davies, I thought that was 29 minus 1, right?
Then it'd be like, oh, wait.
Yeah, but you guys, see, yeah, exactly. So Owen, absolutely correct, okay? All right, now, so if the projections are accurate,
Wait, 829, yeah.
7.4,
No, you said
829.
827 equals.
829 equals, thank you for listening. Thank you for listening. Yeah.
I'm always listening.
Why do we use it with which one's minus 1 though?
The reason you minus 1 is because you already have the first term here. That's why you minus 1. So that's the first term, and then these make the other 28. Very good question. That's why you minus 1, because you have to take away the one that's right there. Nobody ever asked that question. Why is it minus 1? Good job, Celeste. Okay, so now,
Why don't you just not write that?
so if the projections are accurate, how many C days will the band sell during the last week of September, okay? So then we know that answer. We already got it. So they'll sell 74,934, right? We know that, right? So that's our 74,934, okay? So the next one is, when will the total number of copies exceed being sold at 1 million? Okay, now we're going to work this backwards, right? So we are going to take our equation, A of n equals our A1 plus n minus 1 times d. And what I want to find in this case is n. What n represents what week, okay? So I want to find the n. So I want to solve for n. So I want to find n if I make 1 million. So I'm going to put 1 million here because that's what I want to find. How many n's does it take to make $1 million? I'm going to say that again. How many n's or how many weeks is it going to take to make 1 million? So I'm going to put 1 million here and we'll just solve it. So I'm going to go 1 million. First term again is my 9,050 plus n minus 1, and we know d is my 2,353, okay? So what we're going to do is just work it backwards. We're going to find, okay, solve for n, and n is what week, right? So to solve for n, first thing I'll do is I will I'll distribute. That times that, that times that. How's that? Okay. And we'll go 1 million.
Wait, what is this?
Okay. Okay.
Why do you have to do it like that?
There's a couple of ways to do it, Nikolai. But why do I put the 1 million here?
Why do you have to distribute?
I don't have to, but I think it's the easiest way for you to see it. Okay. Equals 9,050 plus 2353n minus 2353. Okay, distributed. You guys see that? 2353 times n is a 2353n, and 2353 times a negative 1 is a minus 2353. Okay, now to continue to solve, I can combine these two because they're both regular numbers, right? So I'll go 9,050 minus 2353, and I get an answer of 6,697 plus 2353n equals 1 million. How am I doing? We'll go okay? All right. So Nikolai, there is another way to do
So
it.
you're just trying to find n.
That's all I'm trying to do, yeah. And there is another way to solve, but I thought this would be the most forward way for you guys to see, okay? Subtract 6,697, subtract 6,697. If I use my calculator, I go minus 1 million. 1, 2, 3, 1, 2, 3. I get an answer of 993,303 equals 2,353n, right? How am I doing, okay? All right, I'm just solving. It's just big numbers, but I'm just solving, okay? Just solving. I'm going to divide it. Absolutely. I'm going to divide by 2,353, divide by 2,353, and divide by 2,353, and I get an answer of about 422.14, blah, 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 okay? So, now the question is, at week 422, we're not going to be quite almost, yeah, does that make sense why I'll round up? Because if plain old 422, we'd be really close to 1 million on that week. Really close to 1 million, but we wouldn't exactly be there, so really we'd round it up to 423. So that week, whatever that week would be, which obviously is many years down the road, okay, for them to make that much money, right? Okay?
They're not doing that well.
Okay? No.
It'd be 8.1 years in the future.
Ah, thank
8
you.
years?
Thank you. Yeah, that's a lot. Yeah, did you divide by 52?
Yeah.
Nice. Nice. Thanks, Aiden. Okay, ready to turn the page?
Yes.
Okay, all right.
It's only 13 minutes ready to sleep.
So here we go. So here's another arithmetic sequence. All right, and let's go ahead and complete the chart as best we can. So it looks like we start with 27. So to do the recursive formula, go 27, and then 27 plus 0 plus 1. So what we're doing is, in a sense, developing the formula we already have, right? So this would be then, if I have a 33, because I'm adding to each time. You guys agree? And then have a 35. Then I'd have a 37. So that's 4, 5, 6, and 7 would be a 39, right? Or I can do the chart on the side if that. But I got everything down there, okay? Now, that's the same thing as 27 plus 2 plus 2 plus 2. 2 times, sorry, that's not right. 2 times 2, 1 times 2, 3 times 2. I'm sorry, I blew this one. That's the same thing as 27 plus 3 times 2, because there's 1, 2, 3 2's. 2 plus 2 plus 2. I am blowing this. The same thing as 27 plus 2 plus 2 plus 2 plus 2, which is 27 plus 4 times 2. But what they're trying to do is make us make the formula. Okay, they're trying to force us to make the formula, okay?
35.
What's that? Well, that's 8 plus 27, yeah. 8 plus 27, right?
No, man, he scribbled out the 7.
Yeah, I screwed out the 7, yeah. So what they're doing, in a sense, is we're working on the formula. So the formula here would be A of n is going to equal our first term, which is 27, plus all these 2's, right? Which is going to still be our 2 times our n minus 1. And what we want to do eventually is come up with our formula. A of n is equal to a1 plus n minus 1 times
Was
d.
there 2 there before?
No, this 2 comes from every time you're bringing in a 2, okay? Now, if we're going to graph this, what do you think it should look like? Zoe, you know, what's it going to look like?
Linear.
It is going to be linear. It is going to be linear. I'm trying to give you the ones you know, right? There you go. Yep, you got this down. So, first term, second term, third term, fourth term, fifth term, sixth term. I like to do my squiggle because we're really going to start with about 25. Let's do 30. Let's do 35. And we'll do 40, right? I like my little squiggle, squish it down, right? So from 0 to 25 squished out of there. And if Zoe's right, we should have a nice straight line, which of course Zoe's right. She's always right. So we got a 27 is my first term, a 29, second term. My third term is a 31. Fourth term is a 33, and it looks pretty straight to me, Zoe. Now, nice straight line, so we know it's arithmetic, don't we? It's arithmetic, which it is, okay? Okay, before I conclude, I want to write these down, okay? We have two formulas, the recursive, and in this example, the recursive would be a1 equals 27, a to the n equals a to the n minus 1 plus 2. Now the recursive formula is nice in the fact that it tells us what we're doing, right? The recursive formula has the beauty that it actually says we're adding 2 each time, right? That's the recursive. We take our first term, we add 2 to it. We take our next term, we add 2 to it. Take our next term, we add 2 to it, okay? But the recursive formula is only good for telling us what's going on. If we want a formula that's going to get us somewhere, we need the explicit formula. And in this case, the explicit formula would have been a of n equals 27 plus n minus 1 times 2. Okay, and that's the explicit formula for this sequence. And the nice thing about this formula is that if I asked you for the 50th term, boom, plug in 50, right? If I want the 100th term, boom, plug in 100. Now, a couple of days ago, it was a good question, Price. A couple of days ago, Price, you saw this 2 here, and you're, wait a minute, that's multiplied by 2, right? So a very good question because we are adding 2 each time, right? And the reason we multiply here is we're adding how many 2's, right? So the recursive tells us what we do. The explicit is a handy formula for getting us to whatever term we need, okay? So let me go ahead and stop my recording.